Okay, pause the video, give this question a go first yourself. Alright, I'm going to go through and basically kind of reteach this. You've got your CPU, you've got your RAM, you've got your hard drive or SSD, which has virtual memory area on it. Okay, so we're going to talk about how this actually works. A couple of things. Number one, we know that RAM is split with your address, location, and then the data and instruction. But I'm not going to talk about things in general terms. I'm going to be quite specific now. What we need is the OS as well to be a part of this equation. The OS needs to know what status or availability there is in a RAM. So that's one thing in terms of memory management the OS would do. So let's imagine this is full, this has got something in it, this is empty, this has got something in it. The OS is responsible for tracking the status of each memory location, but not just that it's full, but also what processes are being executed by the CPU. Okay, so the OS needs to be aware, I know it's address number 1, which is currently in the CPU, and it's data. So it's being fetched, decoded, and executed. So it's what's available, and also what's happening to that process. So part of this is the OS has to track the movement between, so it tracks the movement between RAM and the CPU, but not just between the RAM and the CPU. It also has to track the movement between the RAM and the virtual memory. So remember, when RAM becomes full, data is then moved into the virtual memory. So I'm going to put and RAM and VM. The operating system, so let's imagine right now that we've got, I'm just going to clear this out slightly to make this a little bit wider. So you've got RAM, made that a little bit too big, but whatever. Address 1, address 2, address 3, 4, 5. And let's imagine that we've got Valorant loading screen. This is also part of the Valorant loading screen. It's quite a big amount of processors for the loading screen. We've got another bit of Valorant loading screen. So that could be like the music part. We've got Spotify open, and Spotify again, because Spotify is going to be made up of lots of different processors. I'm currently playing Valorant, so this is going to be needed, this is going to be needed, this is going to be needed. The problem is the loading screen needs one more space in the RAM. Because remember, it's quite a big beast. So the operating system needs to be able to recognize, uh-oh, we need more space in the RAM for the Valorant loading screen. We've currently got 1, 2, 3, but we need 4. So the OS, part of memory management, checks that the processors have enough memory allocated to them, or I've been allocated enough memory in the RAM. Then it recognizes I'm not using Spotify. I'm playing Valorant. Spotify is in my background. It's open, but I'm not really using it. What's it going to do? Well, it's going to take the Spotify and move it into my virtual memory. That's not my virtual memory, that's my virtual memory. And it's going to put the Valorant loading screen into here. So we call these processes, so like Valorant loading screen, Spotify, song select, you know, so one game is made up of hundreds of thousands of different processes. These processes are called pages, keeping it really simple at the moment. So the OS is responsible for moving this called transfer. We're transferring pages between virtual memory and a RAM. So we've got memory management. Operating system is responsible for tracking the status of each address location. So what's available, what's not available, where Valorant is at the moment, the loading screen, is it being part of a CPU, is it being executed? It also keeps track of the movement between the RAM and the CPU and the RAM and the virtual memory. It checks to see that each process has enough space in the memory, and it's responsible for moving things from the RAM to the virtual memory, called that transferring, of these processes called pages. So when RAM becomes full, certain processes, certain pages are sacrificed and put into the virtual memory so we can make space for things we're using. By doing all of this, it allows us to do multitasking, because it doesn't close things off. It doesn't close Spotify. It allows us to use Spotify again later if we need it. So it allows us to, and the CPU to, basically fetch different processes. Remember, it feels like it's at the same time, but it's just rapid, because the operating system tracks everything. By the operating system tracking things and knowing where everything is, it allows the CPU to fetch, decode, execute lots of different processes rapidly. If I am listening to Spotify and playing Valorant at the same time, it would basically CPU, Valorant, Spotify. The CPU will start there, then it'll go to there, then it'll go back to that again and fetch Valorant and fetch Spotify, and it'll do it rapidly in milliseconds without us really noticing. But it'll be the operating system which manages everything and tracks everything for that to happen.